Optimization is a technique to find the maximum or minimum of a function of several variables subject to a set of constraints.
Optimization is a tool with applications across many industries and functional areas. The three most common industries are finance, agriculture, and human resources. In finance, optimization can be used in stocks with portfolio optimization. This will allocate funds to stocks to minimize the risk for a target rate of return. For airlines with different classes of tickets, airline owners can determine how many seats to sell. It can also be used in human resources like crew scheduling and office assignments. Crew scheduling is that given a flight schedule, allocate crew members most effectively to flights. Office assignment is to assign employees to available offices to maximize the satisfaction of the employees. Lastly, on agriculture, there is machine allocation and crop planning. Machine allocation is to allocate the production of a product to different machines with different capacities and meet production target at a minimum cost. Crop planning is that given forecasted crop prices and growing conditions, determine how much of each crop to plant on the field. There are industries that use optimization like transportation, electricity, oil and gas, and many other capital-producing companies. But optimization is still used most commonly in the three areas mentioned above.
Here are some tips to keep in mind when you come across an optimization problem. Tip 1 is to draw a diagram. It helps you visualize the question and come up with the necessary equations that are used later in the question. Step 2 is to convert everything in terms of one variable so you can easily solve for that variable. Tip 3 is to set the derivative equation to 0 and then to check if the critical value or values that you get is a maximum. Tip 4 is that whenever you're stuck, try to remember the context of the story, which might provide some hints when you solve the question.
In this scenario, you're a master architect. Your client, Ms. Martinez, is an avid gardener and wants to build a special fenced-off garden just for her tulips. She has a budget that only allows her to buy 350 meters of fencing. How do you maximize the area of the garden with a given amount of fencing?
The first thing you want to do is draw a diagram so you can visualize the problem you have at hand. You know that the garden is going to have a certain width and length, for it's a rectangle. You also know the two widths and lengths can add up to 350 meters, the amount of fencing she can afford. Thus, the length, in terms of the width, will be 1/2 of 350 minus the two widths. You also know that the width times length results in the area of the yard. If the length is 1/2 of 350 minus two widths, then the area in terms of width is width times half of 350 minus two widths. To find the absolute area, or A, you will have to optimize it by deriving it. A prime is 1/2 of 350 minus 4 widths.
Setting that to 0 and finding the critical value shows that when width is 87.5 meters, area is at a maximum. Plugging that into the length formula yields 87.5 meters as a length as well.
Ms. Martinez is very satisfied with your work. Her neighbor, Mr. Patel, saw your work and would like to also commission a garden built for him. However, unlike Mrs. Martinez, he doesn't only plant tulips, but roses and daisies as well. His budget is a bit bigger, and he's able to afford 450 meters of fencing. He wants his fence to be split into 3 equal sections with fencing, so he has equal area for each of his 3 types of flowers. He also wants the largest area possible for his garden. Once again, the first thing you want to do is draw a diagram. From this, you can see that 6 widths plus 4 lengths has to equal 450 meters. Solving for length in terms of width yields 1/4 of 450 minus 6 widths. Area is thus 3/4 of width times 1/4 of 450 minus 6 widths.
You know that the total area of the garden is 3 widths times length. Once again, you set that to A. Using optimization, you find that A prime is 3/4 of 1/4 of 450 minus 12 widths. The critical value is 37.5 meters, where area results in a maximum. If the entire bottom section is 3 widths, the garden is 112.5 meters by 56.25 meters. At each 37.5 meter interval along the bottom, you know you'd have to create a divider in the garden.
Thank you for listening, and we hope you learned something about optimization.